Hello. Good afternoon, everyone who's joining. We are slowly getting started, and I'll do a short intro to our today's topics and speakers. And kind of in these first 10 minutes, I want to just quickly go over some of the things that we're doing outside of the meetups, and then I'll give kind of the word to our speakers so that they can kind of get on with their topics. So yeah, today is the second event that we are hosting. So we're going to be talking mostly about different Azure services. So this is integration services and also queues in Azure. So we've taken some of the feedback into account and, well, shortened, can lessen the number of topics. And I hope this time we are more kind of development driven, and we have some good samples, which I hope we can share with you in the demos that we do. We'll have some breaks in between. Those are useful for Q&A, but the Q&A is open on the sidebar. So if you feel that you have some questions, feel free to ask them as they appear. I'll try to moderate those and ask the questions to our presenters today. But yeah, so what we are planning and still kind of going to do this year. So this is the second meetup, and we have 2 more to go afterward. Always on Thursdays, always at 4 o'clock. Well, our Latvia local time. It's all in preparation for Open Hack event happening in June. I'll be kind of giving more updates in the upcoming meetups for the Open Hack. But today, I would want to focus more on what we are organizing in parallel to the meetups. So one thing is our Discord channel. I'll post the kind of invite link to you afterwards in the chat, so you can kind of join us on the channel. We've done a quick survey about what people would want to see there, and the feedback overall has been that it's mostly about sharing knowledge and experiences. So at least in my mind, it means that we could be sharing industry news, kind of communicating about our certification experiences, or just helping with questions that people have. So don't be shy, join us, and I'm always kind of ready to kind of pick up somebody who challenges me on a coffee break. So yeah, that's about Discord. In addition, we'll be starting our Let's Build event. Well, not really event. It's a kind of our training program. So its focus is on kind of teaching people how to build working software. So you might have done several tutorials and kind of picking up different components of Azure and trying them out and trying to build some smaller things with that. What we want to do is take this experience and bring it together, what it means to bring to build a larger kind of working software that has all these components working together. And we want to provide you with training materials for that, as well as some guidance from our mentors and some Q&A, if that's helpful for you to kind of build along. While initially we have planned this mostly for students and junior developers, I would say that everyone who is interested is welcome to join. I'll share the registration link later with you, but we're starting next month already. And for the registration, I'll be asking for your email address because I'll need to contact with you regarding the details, how to join and how to kind of be part of this program. So that will be a bit separate from the meetups that we do anyway. And from the other side, if you're a member of the community and want to join and help us, you're also welcome, and reach out to me how we can arrange that in the best way. But yeah, that's the introduction I wanted to do. And I would like to hand off to our expert speakers today. Uroš, word to you.
Okay. Hello. Let me just share my screen in a second. So you should be able to slowly see my screen and me as well. And hopefully you hear me loud and clear, so we can start the first discussion around the API management. So let's dive right into. So hello, everyone. I hope you're feeling well and ready for a discussion around the API management. My name is Uroš Kastelic. I'm working at Microsoft as the specialist for Azure application development. I'd like to share a couple of things about me. So as I said, I'm coming from Slovenia. Those of you that maybe do not yet know where Slovenia is, you can try and search the map where you will find a country that is shaped something like this, like a chicken. And it is very interesting. Yes, there is actually a country that that looks like this. But this image here, it represents a first Slovenian web browser, not the web browser, but a search engine that we had in the early 90s. It's called Matkuria. So of course, yes, things moved on, and then I believe there is no more of this search engine. But yes, this was our Google. Let's call it like this. Back then in 90s. I live in the capital, Ljubljana, but the next picture shows, that I really like exploring. I like mountains, I like nature, taking photos as well. So doing photography. This is not my photo here, but definitely, yeah, it's a nice one. It's from a city called Bled, where there is a beautiful lake with an island and a church on that particular island. So I'm, welcoming you to explore Slovenia, once this situation at least a little bit eases up or gets better. Regarding the technology, I really do like C#. I do like .NET, not because I'm currently working at Microsoft. I did like it also before. I'm a developer by my background. I was working on Microsoft technologies for quite some time, even before joining Microsoft. Currently, I'm focused on, as I said, on Azure and application development, basically migration and modernization with Azure Services. But one of the passions and one of the things that I do is also help customers develop the DevOps culture in the organization. So I really like to see what we can automatize, what we can do with the DevOps, and there's quite a lot of things that you can do with it. Yes, that's a little bit about myself, and let's start with the actual topic and why you are here. So we're going to talk about the API management, but to put it into the context, we need to understand why we're talking about the managing all those different APIs. Well, we see that the world today is a big connected experience. Everyone is connected with different services. Devices are connected to different services, different data, and this goes from applications all the way to different devices, IoT devices, edge devices, cameras. Everything is tied to the to different services through something that is called the APIs. And in order to, for example, help us, do you see my screen? Yeah. In order to help us expose those APIs securely, we do use some services that are capable of exposing, protecting the APIs. And we're going to talk about Azure API Management. So Azure API Management offers you three things. One is to hide the backend where your service actually is from the consumers, right? It provides a single point of ingress. There is like a front door, which is called the gateway, that is capable of routing all the requests from the person or a service trying to request the API or send the request, all the way to the service in the backend that is basically accepting this request and doing some action and then returning the response. And of course, one of the great things about Azure API Management is that it also offers self-service portal for users, developers to get onboarded with what they are using and understand what APIs are available to them, how they can consume them, and so on. So these are the three main things that we're going to focus today. So bringing this into the context of the previous picture, we see that Azure API Management fits into this whole connected experience in a very nice way. So you have API Management as a service, where you as a developer can go to a developer portal, discover what APIs are available to you. Then when you're building a service that will consume those APIs, they will go through the gateway, and administrators are able to use the administrative portal or admin portal available on Azure to secure, write rules, monitor what's going on with the APIs, and so on. So this is, again, same story as I showed you on the previous slide, but a little bit more detailed. So as I said, we have three pillars: developer portal, then we have management plane or administrative portal, and a gateway. And we're gonna look into all of those three things. And of course, I'm going to also show you some demos how to integrate that with additional Azure services or with your existing APIs. But before going into this, we need to understand why Azure API Management. What's the value? Why should you use it? So, of course, it offers you to secure your APIs. It offers you to abstract those APIs. It offers you to give developers the way to discover them. And it's actually a one service that can protect your APIs across multiple environments, whether you have API endpoints or services exposed on or deployed to Azure public cloud, or they are sitting on on-premise environment. You're basically using this one particular service that's capable of accessing and protecting those different APIs, right? It is a native Azure native service. It comes in two different flavors, either fully available in the cloud, or even another option where you can take the gateway and put the gateway onto your on-premise environment or any other cloud where you have your services. So bringing the gateway closer to your services and then transferring or redirecting your user requests through that gateway to that particular service where the user is requesting the response. It's globally available, and it also offers you to deploy the services, deploy the API products, and all the transformation rules in a DevOps-friendly way. So then, what are the scenarios? Anything that you can think of, all the way from IoT solutions that we see nowadays very much used by our customers to basically expose those APIs for those IoT solutions, all the way to the classic web applications, cloud-born applications, serverless applications that basically need to protect those endpoints from the external parties. That we need to discuss, because of course Azure API Management is a cloud service. It is available to be tested and used, of course, on the cloud. There is also the aspect of pricing. Azure API Management comes in quite some different flavors. As a developer, you can go and start using the developer tier, which is a very, very good tier for your non-production usage, for those things where you have to basically just spin up, test, try some things before going to a production or to different stages. It offers quite a lot, actually, this developer tier, and I would encourage you to look at it, try it for yourself as well, and then yes, if you need more than the developer tier, or once you go to, for example, to a production environment, definitely you will need to move forward to one of the other tiers, for example, either standard or premium. But there is also one more, which is a consumption tier. Consumption tier is intended for those serverless applications, such as, for example, exposing the APIs that are developed on Azure Functions or as an Azure Function application, or, for example, on Azure Logic Apps. And it's really a serverless tier for intended for these serverless applications. There are some differences between one and the other. So different tiers have some features. So I would encourage you to go to this website on the Microsoft Azure website and take a look at all these different pricing tiers and what they offer you. Definitely there are some differences. For example, as you will see later on, the consumption tier, for example, does not have developer portal, whereas others do have. So check it out and use the one that is basically suitable for you. Before going into a demo, I'd like to first of all go through some of the slides that will explain, a little bit what Azure API Management is and how to use it. So as I said, there are three aspects of Azure API Management, or three pillars. One is the developer portal, which we will look into. It's intended more for developers to understand, what APIs are available to them, how to use them, and so on. Then we have the administrative portal, and then is a gateway. So the gateway itself, it's capable of accepting the request and then, providing the response. However, through the admin portal, what we can do is we can import all those APIs, and we can provide the policies on what needs to happen with the request or what needs to happen with the response. So what we can do is we can write policies, and those policies, they will help basically to transform the request or the response in the right way. So as you can see here on the right side, there are many different policies that you can select and use in your Azure API Management, and we'll go through some of them. Basically, we're going to take a look at some of those that are most used in the real life. How does it work? So as you will see, there are some policies that can be written on a global level. For example, we want to log all the requests. Then we'll go to the product-specific policies, and the API and the operation-specific. So what this slide shows is that when we come to a specific operation, so the operation is an actual API action, or the method that we are executing. It's, for example, get all products, for example, it could be one of the operations in our API. So that's the operation. API is basically the container that holds all the operations inside. And then the product is something that groups all of those different APIs together. So maybe for our shopping e-commerce website, we have many different APIs, products, carts, and so on and so forth. But they can be grouped in a product, which is, for example, a shopping product. And then we have a global settings that are falling under our Azure API instance, API Management instance. So what I'm trying to explain here on this slide is that the policies that are written on a higher level as a global product and so on are getting inherited by those that are sitting lower, or for example, the operation We'll inherit the policies that are created in the global. However, we can also override them if we want to. So on the operation level, if we need, we can write our own policies, or we can even override some of those policies that are written somewhere higher. So how does the policy or the request come in? So from the caller, we have the inbound policy, which is then taken to the backend, and we can do the transformation while the request is flowing into the inbound state. Then there is the backend, where we can also do some operations in the backend if needed. And then also they are flowing back to the outbound. So this is the response. We can do some transformation on the response. And there is another one that is called the on error. So if anywhere on this path, the request or on the response level, we receive some error. There is another policy which gets information or has the information on what to do in case the error occurs. Okay. So we talked a little bit about the pricing tiers. We said that there is a consumption tier that is very suitable for the serverless applications. And I have an example actually of that, where I have the serverless application written in functions, and it's going to be .NET Core application, and it has some information inside, some APIs. API operations, and then we can expose this function API through the Azure API Management. But not to spend too much time here, let's move forward with one more thing that is very important. Azure API Management offers us a way to version our APIs. This helps us to do changes to our APIs from the perspective of, for example, the policy transformation and so on, without introducing breaking changes to the production. So if for example, consumers are already using some specific version of API, we can still work on our policies, we can do some transformations, we can test everything, and then once we are ready, we can put this to the production. And yes, just a couple more slides, and then we'll go to your questions and to a demo. I mentioned already the self-hosted API gateway. So in case where you have a setup, something like this, right? You're using you're used to multi-cloud deployment strategy. You have, for example, hybrid cloud strategy. You can deploy a self-hosted API management gateway to an environment where your APIs actually live. This will help you transfer and basically reduce the latency, so that the calls are not going first to the Azure API Management, where the central one, where everything is set up, but they will be transferred directly to the closer location, to your API gateway, where the API operations live. So, as I said, reducing the latency and also sending the load to different locations. So how does the self-hosted gateway works? Today, Kubernetes is very much popular. Containers are very, very popular. And here also the self-hosted gateway is something that is using a Kubernetes environment. It's a Dockerized image that you basically deploy to your Kubernetes environment. And it's capable of running, for example, the self-hosted gateway. So that is basically how the self-hosted gateway looks like. It's a managed gateway that is basically containerized and is working on your Kubernetes environment. Okay. So then, how does the experience look like? How would you set up API management? Well, obviously, there are multiple ways depending on the scenario how you what kind of applications you have. But for example, like this, it's a very easy enterprise integration. We have the API management that connects to the logic apps or exposes the logic apps as through the API. And there is also some web services sitting somewhere in the backend system that are also exposed through the API gateway. Also AKS, microservices, we can expose those services through the API management that can sit in front of our AKS environment. And for microservices in general, there is multiple different options how to set this up. For those of you that are familiar with Power Platform and specifically Power Apps, that is a low-code, no-code environment for developing the applications. You can also leverage integrations with Azure API Management to basically connect your APIs and just expose them to your users that are using Power Apps to create those very interesting mobile applications. So with that, I'd like to check with Yanis if there are any specific questions before we go to a demo.
Okay, none have yet been typed. Maybe somebody will be brave enough to ask, but I did have some of my own, if you may.
Sure.
So regarding the policies, for me, it's kind of, I've used, this API management as part of our, in the project that I work in, we have it as part of our solution, but I haven't really done any hands-on things, so I might have some funny questions. So the policies, do I get it right that it's quite useful if we have older services and want to teach them kind of new tricks? So I don't want to rewrite my old service, but I want it to behave like a modern web service in terms of authentication and things like that.
Exactly the case. For example, even where we have some services that are exposed outside or sending the response in an XML format, for example, but our device or maybe some other application accepts the JSON format. What we can do is through the API management, for example, just transform the response from XML to JSON. We can add some, for example, authentication layer on top of it, so that, as I said before, we additionally secure the backend, or we can do some XSLT transformations if needed, or something like that, right? Yeah. So
basically, I could actually filter out if it always was my internal API. I'm now opening it up for someone else. I could filter out some of the responses which I don't want to get out, so to say.
Yeah.
Okay.
Yeah, this is a very common scenario, for example, to protect your some specific set of APIs. To protect them, basically, we allow just certain IPs to basically access those APIs.
Okay. That's it with the questions from my side, and none have appeared.
Okay.
So I think we're safe to go to demo.
Yeah. Before going to a demo, I just want to explain one more thing. So as I said before, I'm very I'm looking into how we can automatize a couple of things, how we can basically deploy them in a DevOps way of work. If you remember from the last time where there was a DevOps discussion, the DevOps consists of different phases from planning, developing, building, and so on, all the way to deployment, right? So here, just to give you a context of how and what you could do with Azure API Management, because Azure API Management in the backend is utilizing Azure Resource Manager to provision the service. So what we could do is we could utilize Azure Resource Manager to configure our service, plus to configure our APIs. So what this means? It means that whatever we will later show you in a demo, this can be also an ARM template. And this allows us to basically then put these ARM templates into a repository, so version control them, and when we need them, we can leverage them for provisioning environment, deploying APIs. If there are some changes to the APIs done, they can be done in a coded way through the templates, for example. And they are also version control, plus they are then we can replicate them into different environments. So here we have, just for me to expand everything, we have two approaches, right? One is when a person that has experience with ARM templates prepares the APIs, prepares the environment through the ARM template. So what they can do is they can basically use the Azure DevOps repository, or GitHub repository, and put inside the templates with the master template that links to service template, API templates, and some shared template. Then, we basically use tools to import these templates into the API management or Azure. And there is a tool that is called Creator. It's part of our Azure API Management tools set, and it creates Azure API Management from these specific templates. Then development or developers, what they can do is they can fork this from the published repository into their developer repository. So now they will have all this code in their developer repository. They can work on it, and they can also deploy it to development environment, for example. It can also go from the right side to the left side, which might be more convenient. So going first to the development environment, and then from here to the production environment, of course. But what about those developers that do not know or have experience with ARM templates? What they can do is they can extract the templates from the environment, from the API management. And there is a specific tool called Extractor, and it basically looks at the Azure API management, looks at all the APIs, and basically creates templates. So now what we have is we have developers that can either import or export those APIs. They can write them. They can create their own APIs, own policies, and basically then generate the templates, have the templates as ARM template, and then once they are finished with the changes to their dev environment, they just commit that to master. But before going to master, of course, there has to be a pull request mechanism that validates everything, and then does the, for example, automatic merge to the production environment. And in the production environment, we have some trigger that automatically then, for example, does the release to production, right? So that's the DevOps way how you could automatize the deployment and development and the deployment process for the Azure API management. Now let's go to a demo. I'm sure you are waiting for this one. So here we have, first of all, the link to the website where there is more information about the API management. I'll say, just when you have time, go through it. There is a documentation here, customer stories, and the pricing, which explains a little bit more about the API management. The documentation, whenever you'll have questions on how, for example, the policies are constructed, what kind of policies you can use, look to the documentation. It will definitely help you understand what are the different options. So once we want to create the API management, obviously we need to go to Azure portal. We search for the Azure API management. We click create. We provide some of these properties or information, such as, for example, the resource group, the region, as Azure is geo service, distributed service, and then we have the resource name here. What will be the name of our API management, organization name, and administrator email. So here we can select the pricing tier, as I said before, the consumption, basic, standard, and so on. Keep in mind that also the SLAs are very much related to the pricing tier that you select. There is also some options for monitoring and so on that you can configure while you're configuring the API management, but it takes some time to provision the API management service. So we will not do this now. I already have it created, but I would like to say that here, when you will provide the administrator email, once this provisioning completes, you will receive an email stating that the API management has already finished with the provisioning process. So here we are. This is my API management that I have created for this demo, and immediately what you can see here is that we have this developer portal. Here, what we are seeing right now, this is the management plane or the administrator portal, and then there is also the gateway. So the gateway, we don't see it, but it is there, believe me, and it is exposing or helping us expose those different APIs. So what are those APIs? Let me zoom out a little bit. First of all, if we already have some APIs or different services available, what we can do is we can easily connect to them through the Open API or WADL, so basically the RESTful API XML representation, SOAP, or we can connect even to the existing logic apps or function apps, right, where we already have created them, and they will be protected with the have you lost my screen? Let me double check. Someone else started sharing. Yeah. Yes, I will
please
share.
reshare. Sorry.
Yeah. Just let me share one more time. Okay. So now what we have here is different APIs. We can also add one. We can have a blank one if we want to. And these blank APIs are very, very interesting because what we can do is we can create also mock APIs. And I have one here. And how does it work? If, for example, we are trying to develop a service and or an application, but our API team or a team that works on some backend services have not yet produced anything. So instead of waiting for them, if we know what our service is going to accept as a response, and so what our service is waiting to receive, what we can do is we can create a mock API with all these different operations. So we can add a new operations here saying, this is going to be, so for example, the post mock, and we say we're going to have a post operation, and it's going to be exposed here, for example. We can tag it. We can provide the description, and here we can also specify, if we need some of the headers in the request or in the response, and so on. So what we can do is we can easily save this operation. So now we have a post operation, and we can easily mock the responses. So as I have it here, for example, when a service calls this particular API operation, it will basically receive a mock response. I say just receive 200 mock status code, which is okay, and get me some sample response back, right? So this way, we can proceed with the development of our application, specifically, maybe some web application or mobile application, have the mocks here in place. But then later on, when the API team or backend services team creates an actual backend service, we can easily just connect it to that one, right? So that's one example of the transformation. So like I said before, the gateway allows us to do some transformations on or the processing of the request inbound on a backend level, outbound level, and there is also the on error level. So what we can do is, for example, we have here a demo conference API, and the demo conference API allows you to allows us to see here all of these different operations. So I mentioned to you before, we have the APIs on one level, and then inside the APIs, these are methods or operations. So here we have get, post operations. It could be also some other operations if needed. And for example, get sessions here allows us to get the list of all the sessions, where we can also provide, if we want, with some query parameters. Like, for example, we would like to get all the sessions that are specific to some speakers, or for example, on a specific day or with some keyword. So these are the query that parameters that are optional here for our request. And then I'm doing some processing. What I'm doing here, and this is a policy, I'm saying I would like to limit the calls that can happen against this specific API. So I'm saying 3 calls in one after the other, and then there is a renewal period of 15 seconds. So I can call this API for the 3 times, and then on the 4th time I'll have to wait for 15 seconds before I do another call. So this is why you just throttle a little bit all the requests. Then what we also have is we can do some caching. We are doing caching on the response. So what is going back to the consumer? We are caching these for 30 seconds. So the first time when we call the service, there will be a bigger amount of milliseconds that are required in order to process the request. But then next time it will be much lower, right? Because we have the cached response. So what else we have here? We have the redirect content URLs. So for example, in our response, we are returning some URLs that then our application will be using for example, to showing the, blobs, or for example, to giving the information about some specific links. If we want to protect that information in order to not to show it in the response like that, what we can do is we can also redirect the content URLs, and in this way, all the URLs that are pointing to our endpoint will be protected by pointing it to our API management. So that's why we are hiding the backend endpoint from our users. We can also play with transforming the headers. So we can look for some specific header property, and we can delete it, update it, change it, whatever we want to do. And I said that we are caching it. So this is all fine. As an administrator, I can play with the policies, but what can I do here actually? So as an administrator, I can group those APIs into different products, which I already mentioned. And these products are allowing our developers, our consumers, to subscribe to those products. And only those consumers that are subscribed to those products will be able to utilize or consume those APIs. So I will show you this in a minute. This from the administrative side, what I can also do is I can also test it right here immediately in the Azure portal. I say I would like to test this service, whether the policy that I configured works fine, and I can send the request here. And hopefully, everything will work fine, and we'll get the response. But as usual, demo gods are delaying a little bit or sleeping a little bit. So here we have the response. So it's 200 the response. These are all the URLs that are now protected and showing towards the API instead of the endpoint. And as you can see, I also have some removed some of the headers from my response. So what else I can do? I can have revisions. If I want to do some changes to my APIs and not introduce any breakable changes, I can play with the revisions. I can create a new one, new revision, and then play on it. And then from that particular revision, create a new version, which is then sent to developers to test, and so on. So that's, let's say, in general about the APIs, and which I already mentioned. You can group those APIs into products, right? So products define who has the access, first of all, to get. Which groups of users or consumers have the access to subscribe to those products. Inside the products, there are APIs, and inside the APIs, there are operations, like I said. So So that's the first thing. So which groups of users have the access, and then we can also see here who has subscribed already, right? And now from the developer perspective, to all of those of you that are actually developers trying to get benefit of those of the developer portal, you know, this is a developer portal which is highly customizable. As an administrator, I can play with the layout, I can play with the information that is available here. And as a developer or as a guest, I can get the list of all the APIs. And as you can see here, there is a difference between what I see here and what is exposed on the API level as I am here at administrator, because there are different, as I said before, products and permissions, and I'm allowing guests to see only these products or APIs. But still, as a developer, I can come in, I can see all the APIs that I'm subscribed to or that are available to me. I can see the list of them. I can see even the documentation. And if I want, I can even try it. So here, I can try it from the browser immediately, but I can also, if I want to implement this in my application, I can also look for the code, for example, in C# or let's say in PHP. So this is the snippet of the code in PHP that allows me to call this API and get the response back. So this is the developer portal. And of course, I see also the available products. Here I'm logged in as a guest, but I can also sign up as a new user. I can also come in, I can sign up to this API management. I can provide the email, password for this particular API developer portal, and then I can sign in. And then once I sign in, I will have access to those products that I have permissions to or that I have subscribed to. So you know, that is very short about the API management. There is a couple more things that you can do. For example, you can import the service with the APIs into the API management. You can also import the serverless function apps that are available that you have created directly into the Azure API Management by just simply going to the function app here, browsing for it, adding it, and it will grab all the definition of the API and put it into the API management for the consumers to use it. With that, I'll end my presentation. I would just like to point you towards the customer stories, where here you can read more about all the different cases, customer cases where customers have used API management and why and how they use it and how it solved their problems or challenges. So with that, I'll bring back to Yanis for some questions.
Yeah. Thank you for the presentation, and we do have a question, so I'll read it. So what's the easiest way to infrastructure as code the API policy? Is it defined via RM that is in JSON, but the policy then is in XML, or can the policy be defined also in JSON?
Okay, I will, if I may, I can, I'm still sharing, so I will show you one more thing here. So ultimately, the policies or the APIs, so this is what you get out from your API management once you do the extract through the extractor tool. And all the tools are available online on our documentation site. If you go to, for example, search for the CI/CD on Azure API Management, you will get the access to those tools. They are available here on the GitHub site. And there is this creator, which creates the API management from the resource manager templates. And there is also the extractor below, which gives you the ability to extract the existing policies. Now, regarding the policy question, like I said, ultimately they will be available here in the JSON format. So the information about the APIs, the information about the policies, everything will be here. The policy itself, if I go back somewhere where I have it, how does it look like? If I go to this one, so here, as you can see, it is in an XML way written, but there is also a possibility to ingest some logic, for example, that I don't have it here, but there is some specific logic that you can just which you write in a C# style of way. However, yes, the policy itself looks like a XML, but once you extract it, or how it is represented then in the in Azure API Management for the service itself, it is like this in a JSON format. So, for example, yes, this is how it will then look like at the end of the day.
So to clarify, it's represented as XML, but underneath that it's not really, because it can do much more than just XML.
Yeah, exactly.
Okay.
Exactly.
Yeah, and do comment if this didn't quite answer your question. But yeah, currently we then let me share the break screen. We have something like 10 minutes then as a break, and let's start kind of continue at 5 o'clock. Well, 5 o'clock my time, but approximately in 8 minutes, unless you have some more questions. And if you do, please ask them, and we'll do our best to respond. Yeah, so we're about ready to continue, and Alexander, welcome.
Yes, hello. Nice to meet you and nice to hear you this great day. So, today we'll talk about the queues and about the using of queues on Azure. And before I will start, I want to maybe have a short conversation with you, Yanis. What do you know about the queues?
Queues.
Yes.
Well, I'm mostly familiar with the old school queues. So my MSMQ was my bread and butter 10 years ago in the project. So, well, everything very local. But for Azure, well, what I've heard is kind of all this IoT thing basically runs on queues, just because of the sheer amount of data.
Yes, yes, and queues are used not only in IoT projects, queues are used in a lot of other types of projects. So today we will discuss what is queue, how we can use queues, how does it works, and so on. So, do you see my presentation?
Yes, we do.
Yes, we do. So let's start, I think. What we will talk about today. First of all, let's look to the queue theory. As I said, we will try to talk about what is the queue, which type of queue we can use, and how does them works. Let's look at the real process, how one of the queue types that we will look at is working. After that, we will switch to the queues in Azure. Let's see what types of queues do we have in Azure, and when we should use one or another type of queues. And in the end of my presentation, we will try to see how we can use queues in IoT project. I will show you two types of queues. We will try to use Event Grid and Event Hub. So, but before we will start, I want to tell you a little bit about me because I think you need to know why you should hear me, or maybe you should hear some other more experienced guy. But anyway. Personally, I worked with development more than 10 years. I have experience with embedded development, with microcontrollers, with Windows development, and now I worked as a cloud solution architect in a company with name Viseo in France. And now I have a good experience with also with cloud architect. And one of my best things that I did, I think that I made IoT service in the Yandex Cloud. Yes, I'm born from Russia, and I'm Russian guy, yes, but now I'm living in France. And 2 years ago, I was managed creation of IoT service in local Russian cloud, Yandex Cloud. So it was this story from scratch, and we together with the team made the service, and now it's in the production and works with a lot of clients. So also I have a certified cloud solution architect state, and also I got all three possible awards from Microsoft, most valuable professional, regional director, and Microsoft certified trainer. So usually here I asking people to tell a couple of words about themselves, but today I'm speaking in online format, and of course I can't hear you. But if you will have some questions or something to say me during my presentation, please write your information or your text to the chat, and I think I will be able to read it. Okay, so what is the queue? I got this text from Wikipedia, and this is, I think, one of the best starting points if you want to know about the queues. So in computer science, the queue is a collection of entities that are maintained in a sequence and can be modified by adding of entities in the one end and of the sequence, and try to remove entities from the other end of the same sequence. So on the right part of the page, we can see the queue. So this is the sequence of elements. Queue usually has back or tail and front or head, and you usually add the new element to the back of the queue or to the tail of the queue. This process has name in queue, and when you want to get information or entity from the queue, you need to take it from the front or from the head, and this process has name the queue. This is the first and maybe the simplest thing that we can show about the queues. In real life, of course, queues are working a little bit more complex, and you can, for example, not only the queue, but you can try to pick information from the queue, from the front of the queue, to understand is there any entity in the queue, or you need to get the entity and read it without the queuing, without removing it from the queue. So real queues are usually have much more features to support all necessary requirements of software application of the services for implementing their own features. So why to use queues? We understand now what is the queue, but why we need to use it? First of all, it's making your service or application much more faster and much more independent. What does it mean? This means that if you will have two processes or two services, and one service should send data to other service, or one thread inside of your application need to send data to other thread inside your application, if you will not use queue, then sender should wait. Sender will send information or data to the receiver, and if sender wants to send one more piece of information or piece of data to the receiver, sender should wait until receiver will finish its task and finish working with the data. If you will use queue, sender can work independently. So sender can send information anytime when it wants, and receiver will get the information from the queue anytime when it will be ready. And this means that a sender and receiver can now will not have any reference to each other, and this means that sender will work separately, and usually this processes will work in the same time, and this means that your application or your system will work faster, because you will have two independent separate threads of your commands or of your business logic. Second thing is increasing of reliability. For example, if you have queue with 2 senders or 2 receivers, if one of sender or one of receiver will be broken, other parts of your application will continue to work. And this means that you can add the more instances of your services or of your applications connected with the queue and support fault tolerance, and this will make your application much more reliable than working without any queues. So, like the text here, queues make your data persistent and reduce the errors that happen when different parts of your system go offline. Scalability. This is more or less the same, but the goal is a little bit different. So this means that if you have a process with one sender and receiver, but sender starts, for example, to send much more data than receiver will be able to process, you will be able just to add the new receiver, like on the second screen. So, for example, sender can send 10 elements per second, and your receiver can process only 5 elements per second. You just can add the new receiver. Because your system works independently, so sender and receiver are working independently, so you can add new receiver, and this will balance your application, and this is the example of how you can use queues and the processes to increase your scalability and to scale your application. And one important thing is decoupling. This means that, as I said, this means that your parts of your application will work independently. And I think this will allow you to simplify your code. This will allow you to easily make changes inside of your system. For example, if your one sender works independently and encapsulates all its business logic inside of this component, you just can make the changes inside of this component, and all the changes will not affect all the system, all other parts of the system. So you know that I wanted to show you, maybe you know, there is a very good book, Pragmatic Programmer. So it's some kind of classic programmer book, and they, in one part of this book, authors discussing about independence of the different models inside of applications, and they call this like orthogonal, because as I said, one part of application should not be related and to other part of application. They should be independent. And if you will have as much independence between your models or your part of your system, then you will have more stable and more controlled system, and more fault tolerance and so on. So this is now the containers or microservices use the same ideas when you have small system or small service for one small task, and these small services communicate to each other and encapsulates inside of each other their business logic, and this is the result of the idea of independence of the services. And without queues, this idea can't live. You need to communicate. You need to have some something to communicate with microservices, and queues are very good. And I think only one service, only one feature that you can use here. So how queues are working? We discussed that queue is some amount of data that we can put in the tail and get from the head, but we saw in the first page that the first data will first queued data, that first element that we will put in the tail, we will get the same element on the head. This queue has name FIFO, first in, first out. But you know that in real world, not all queues support FIFO feature. A lot of queues will not support FIFO, and will give the elements not in the same sequence that they came to the tail of the queue. Why? Because, as I said, the queues are internally very complex, and if you will have different threads inside of the queue, if you will have different receivers that are subscribed to the different threads, sometimes it's very hard to support FIFO type of the queues. Other types of the queues are related with delivery of the message. So there are three types of delivery information inside of the queues. First of all, it's at most once. What does it mean? At most once means that you will receive the element on the receiver only once. And if you will not if you will not read this element when the element will be able for you, you will lost it. This means why? Because this type of the queue give you guarantee that you will get this element, but only once. You will not receive this element twice or three times. But in other hand, if you will not get it, you will lost it. Second type of the queue is at least once. At least once means that you will have the element from the queue at least one time. This means that you will have a guarantee that you will receive your element in any way, in any case. Like, for example, TCP and UDP. UDP packet will be sent to the receiver, and if receiver will not be enabled to get it, the UDP packet will be lost. But if you will send TCP package, will give you a guarantee that the receiver will receive this package, but the time and the amount of resending will depend on the situation on side of the network. In the at least once queue, you will see the same. So when the receiver get the element from the head of the queue, it should say to the queue, okay, I get it. But if the queue will have a time gap before between this signal from the receiver, it can try to send the same element once again. So there is a high chance that the message will be delivered again. So it's a chance to duplicate data for the receiver. And third one type of the queue is exactly once. Exactly once means that there will be only one and only once message delivery. It's very hard. And most of the queues don't support this type of the queues exactly once, because in the real world, in the real queues, in the real systems, it's really difficult to guarantee that receiver will always receive the element from the queue and will receive it only once. Usually queues realize at least once, and in additional they have deduplicating features that allow you on the receiving side understand is this the first message or is the duplicate of previously processed message. So how usually queues works. Let's see what we have when we are working at least one queue. So we have a sender, we have the queue, and senders send the element came to the queue, to the tail, and when it will be at the head of the queue, receiver can ask the queue, is there an element? Queue will send it yes. We have the element, and receiver can get the element from the queue. This is the pooling model, but some queues supporting subscription. So receiver can subscribe to the queue, and the element, when it will be ready, will be sent to the receiver automatically. But for the at least one queue, the element, when it comes to the receiver, the element is still stay in the queue. But at the same time, yes, at the same time, receiver working with the element, and the element is still inside of the queue, but the element will be marked as processing. And this means that other receivers, if they subscribe or they try to get data from the queue, will not get this element. And if you have a FIFO, first in, first out queue, for this type of the queue, other receivers will wait until this receiver that get our element will finish processing of the element and will delete this element from the queue. Only after that, other receiver or the same receiver will be able to get next element, because we need to save the the order of the elements. If we will not, use not the FIFO queue, then when one receiver get the element and mark it as processing, other receivers will get other elements and mark them as processing, and a lot of type of receivers will be able to work in the same time, in like a parallel process. And this is typical situation with the queue, with, for example, with events, when you need to just to know about events, and you don't have any requirements to save the order of the elements inside of the queue. But if you are working, for example, with data stream, with stream from the devices, or with stream from, I don't know, from other system, and you need to store the order of your data, you should use FIFO, and you will not be able to receive data from one queue from one queue, you will not be able to receive the data until next data until the current data will be processed. But you can have in the same service, you can have 3 or 4 queues with the same elements, and in this case you will be able to try to work with 2 or 3 or 4 receivers in the same time. So when we will talk about queues in Azure, we will see that some types of the queues can use different partitions to work with data inside of the queues. So, and after receiver will process the element, receiver should explicitly send to the queue command to delete this element from the queue. And after that, next element, if this queue is FIFO queue, first in, first out queue, this element, next element will be able to read from the receiver. So let's see to the I think most famous queues. I mentioned here 3 queues. First of all is Amqp, second one is MQTT, and third one is Kafka. I think that you at least once heard about one of these queues, and I want now to tell a little bit about these queues to give you knowledges what is the difference between them and how to use it and where to use it. So first of all, the Amqp and MQTT is not the frameworks, and this is an some kind of open source of open standard that describe how the queues should works. It's some kind of protocols. So these standards or protocols have different realizations. We will see it on the next slide. And Apache Kafka, in the opposite to the MQTT and to the Amqp, the Apache Kafka is the framework. So it's not a standard. This is the software that you can use inside of your system. Moreover, this is not just a simple software. It supports scaling. It can be used in the cloud environments and so on. So it's a huge enterprise-based solution to communicate with your data inside of different environments with a lot of codes, with a lot of services and so on. MQTT and Amqp usually used in smaller application. MQTT is a lightweight protocol for devices, for IoT, and MQTT became popular when IoT came to the peak of hype, and before that, MQTT used only in small application that not so many people know about this protocol. Amqp was born, I think, maybe 10, maybe it's quite old protocol, and it's a little bit more complex than MQTT. It has more features to support routing, message orientation, and so on. But in other hand, MQTT takes more CPU power, RAM amount, and it's a little bit harder to support it on the devices. But for the application and for the services, Amqp is more good because it supports more features to communicate and to store data and so on. So as I said, AMQP is more complex. There are some different realization of AMQP. The most, I think, famous is RabbitMQ. RabbitMQ also has MQTT realization, so it's a framework like a Kafka. And usually, if you will try to find something like MQP versus Kafka or something like that in the internet, you will have a lot of articles with description what is the difference between AMQP and Kafka. MQTT is also has different realization. The most famous is Mosquito. Mosquito is an open source realization for different platforms of MQTT, and usually if someone using MQTT for IoT on the local machines or on the local services, they use Mosquito as a MQTT broker. And yes, AMQP and MQTT and Kafka working are with brokers. Broker is some kind of the server that receives messages from the senders, and this server will choose and control who will receive this message from the different receivers. So client will send information to the broker. The receiver should subscribe to the different threads or different queues inside of these protocols and systems, and the broker will decide, will know this information, which receiver is subscribed to the one queue, which receiver is subscribed to the other queue or topic, and the broker will decide on each new message from the sender. The broker will decide to which receiver the message should be sent. So to support scalability of the system, you can have 2-3 brokers. Each broker can have connection with other brokers and so on. So system can be very difficult here, and it's this one of the many reasons why you should use cloud realization of the queues, because when you want to have, as I said here, reliability in your system, you need to support reliability inside of the queues, and this is not the simple task, because when you will control a lot of brokers, a lot of links between these brokers, it's hard to support and to supply this system. And when you will use cloud provider and cloud queues, you will get the scalability and reliability from like a box solution, and you will need just to use the queue like the queue without any additional administration or supporting. So here is it, the link about the queues. If you want to understand more the difference between AMQP and MQTT, you will be able to use this link. There are a good table where you will find this description of different part of the protocols and comparison of this part of these protocols. And now I think when we are understand what is the queue, what types of the queue can be, and how they can work, and where they can work, we can now switch to the queues in Azure. I can recommend you to see this article in the Medium. You can find there a good short overview of all types of the queues inside the Azure, and I of course will say about each queue a couple of words here, but if you want to learn more, of course, you can go to the official documentation of Azure, but also you can find a lot of articles like this one with overview of the queues. And now I want also give you an example where the queue can be used. Example from the desktop desktop software. I think that all of you are using, not all of you, but most of you are using Windows, and all of you know that Windows have Windows operation system has Windows UI inside of it, and inside of Windows UI, when you are clicking on the button or you are sending some I don't know, clicking pushing the button on your keyboard, each action from you will be sent to the internal Windows queue. The name of the queue is Windows procedure, and each action will be inside of the window. There is a thread that will read each action one by one, and we'll process this action, and we'll change the window. For example, if you click by mouse to the button, this function will send the event to the button on click event, and so on. So one of the main and the good examples of the queues inside of the Microsoft environment is that queues are using inside of the UI, inside of classical UI, window UI, to handle actions from the user. So when we are back when we will back to the Azure. In Azure, the queues are a little bit different. It's services that you can use inside of your systems and your application that should interact with each other. There are 4 types of the queues in Azure: Azure Service Bus, Azure Event Hub, Azure Event Grid, and Azure Queue Storage. But before we will go forward, we need to understand the difference between event and message, because some services are working with messages and some services are working with events. So you can find this text and this description inside of the official Microsoft documentation here about documentation about Event Grid. So documentation said that event is a lightweight notification. For example, notification about condition change, or about that user clicked to the element of the UI, for example, and the publisher or sender of this event has no expectation about how the event will be handled. And usually event doesn't include inside the big amount of data. Usually, if the event wants to send the data to the receiver, if the service or publisher wants to send the data to the receiver, publisher should use reference to the data, but not include all the data inside of the event body. Message is the opposite of the event. Message is the data, and event is the notification, but message is the data itself. So message is the usually it's a raw data that produced by one service and sent to the other service, and usually the publisher of the message has expectation about how the consumer handles the message. for example, in IoT, your device will send the raw data, I don't know, for example, temperature measurement or humidity measurement to the IoT Hub, and this will be the message. After the IoT Hub, if you will want to get information about that message is received, you will produce the event. But if you want to get the message and to show it, I don't know, on some window, or to store the message to the database, to store this data to the database, you should use the message type. So device is connected is the event. Device is sent. Device sent the data to the cloud is the event. But the data that was sent is the message. And this is the general difference between event and message. So let's look closer to the different types of the queues inside Azure. So event grid, as we are discussed early, event grid has event in its name, and I think you now understand that event grid works like Event Hub works with event, but event grid is event grid is not a stream of events. Event grid using usually for reactive programming. This means that you can set this service to easily react on different events inside of your system. And moreover, event grid can get events from different services itself, or from on-premises system, or from user system, and you can use event grid to, I don't know, to send an email, or to make a tweet, or to integrate and run the task on some system. So the general purpose of event grid is reactive programming. Event Hub is a pipeline. So the idea of Event Hub is the stream of events. And usually Event Hub using to send telemetry data from one point to other point. And this is interesting because in the event grid documentation, we can find that event and message description, and we can understand the difference between it. But you know that Event Hub is the base queue for IoT, and IoT Hub that used for to connect with devices has Event Hub inside of it, and use Event Hub inside of it to send the messages from the devices to other services. I don't know where is the. I don't know that this is the mistake, but this looks a little bit strange, but salary, that's it, that's his life. And the difference between Event Grid and Event Hub is that Event Grid, as I said, worked with the separate events, and Event Hub can create the stream of the data, and you can work with this data like with the stream. I will show you the services that you can use to work with this data. Service bus, it's a high value enterprise messaging. Usually service bus can be used for process orders or financial transactions, and service bus, it's service bus usually using to work between services. Event Hub usually usually used to work between parts of the application. And last type of the queues inside of Azure is Azure Storage Queues. Azure Storage Queues, it's a really simple messaging between the services, and the main feature of Azure Storage Queues that you can store there large amount of data, more than 80 gigabytes inside of the storage. Azure Storage Queues is the part of Azure Storage Service that contains also table storage, blob storage, and file storage. And why it can be useful when you are sending a lot of data from some services and you are not receiving this data in real time. So you can store your messages or your data in the queue inside of the storage, and you can get this data time from time. I don't know, each 1 hour or each day, and this queue will be very useful here, and it has very simple interface and very simple logic. So from the first view, all these types of queues are the same, but they are usually using in the different application and different types of application. So here we have one more table. Queue storage and event grid is serverless grids, so they are using to communicate in apps, in applications, as I said. And the weakness of these storages or of these queues is that sometimes that they are not supporting ordering of the messages. Event Hub is, yes, Event Grid, of course, will not support ordering of the events inside of it, because all events should be processed in the same times. And as we saw in the example, if you are not using FIFO queues, you can't, you will allow receivers to work in the same time, but you will not be able to save the order of the data. So Event Hub and Service Bus can save the order of the data and can support FIFO queues. Service Bus also has geo-replication and a lot of additional features like deduplication, as I mentioned earlier, to understand that you will have the same message or same event once again. And Event Hub limits the amount, the size of the element, but it supports a lot of messages in the stream, like megabytes. But for example, queue storage supports gigabytes of messages inside of the stream. So Event Hub is big data queue, Service Bus is enterprise queue, and Event Grid and queue storage is serverless queues. So as I said, if you want to learn more about these queues, you always can use the documentation and try to find some articles. And but now let's try to look a little bit closer to every type of the queues. Service Bus, as I said, it's a enterprise queue that supports different models of consumption, different models of using. For example, one of the features of Service Bus is that letter queue. This queue will be used when message can be processed by any receiver, and this that letter queue gives us ability to save the message in any case. So if you will have an error or will have a problem with your receivers, your message will be anyway saved in the dead letter queue, and you will be able to get this message from this queue, and will be able not to lose this message. Azure Service Bus support different consumption modes. It supports duplicate detection, as I said, that you can have ability to get only one message without any duplication. Delivery guarantee. So as we looked early, it supports at least once, at most once, and efficiently once, exactly once, because it can detect duplicates. And Azure Service Bus can guarantee first in, first out using sessions. So all the hardest features are included in Service Bus, and this makes this service, this Azure service, good for the enterprise and high load solutions with geo redirection and high availability solutions. Event hubs allow you to work with a lot of sources and a lot of receivers also, but it doesn't have all these features, and but it has its own features. You can use different protocols to work with Event Hub. You can use also SDKs, and there are a lot of libraries for different languages that you can use to work with the queues. But natively, you can use HTTP and AMQP protocols to send the data to the Event Hub. Also, you can create different partitions to split your messages between the receivers, between the groups of subscribers. And also Event Hub contains consumer group. So using partition in consumer group, you will be able to process the data with a lot of different subscribers, and you will be able to control your data between subscribers, who will receive the data, who will be able to receive the data. For example, you can send one type of data to one partition, second type of data to another partition, and using different consumers groups, you will be able to create 2, 3, 4, and more receivers for each partition, and there will be different separated streams of the data inside of one streaming service, inside of one different queues, inside of one service, Event Hub service. So Event Grid, next service, as we said, it's not the stream, it's a service to make reaction of the events. So Event Grid can get events from a lot of different services from Azure, and not only from Azure, and can send these events to different services in the Azure and in other services using webhooks. For example, you can use device connection event in Iot Hub and send this device connection event to the Azure function and or to the webhook, and use this webhook to generate an email for people or for person who is responsible to control the devices. Or you can use, for example, Iot Hub or Service Bus message, or even you can get data from the blob storage and send it to Azure function to make something with this event to run the code. On you can send it to the Logic app. So this is some kind of a broker or some kind of hub that you can use inside of the Azure to control event flow from services to the from one services to different services. Okay, is there any questions right now? I see that no. Okay, let's go forward.
No questions currently, but I'll maybe interrupt you with one of the anecdotes related to kind of this first in, first out, just to give context why it's important. Because for me, it was something, well, if it's in rare cases and the kind of documentation mentions it cannot quite guarantee the sequence of messages, it sounds like a very rare use case when it becomes important. But of course, Murphy's law dictates that when it will become important, it will have huge consequences. And the one kind of use case where I saw this happen was in banking sector, where kind of trades, amounts, and kind of costs kind of directly impacted the next trade in the order. So once you mix those up, and that's kind of something that happens just randomly with high quantity of data, it starts to kind of have very kind of funny real world consequences on things.
Yeah. Yes, I agree. So thank you. Okay, Azure, last one that we should talk about is Azure QE storage. So as I said, QE storage is the part of the storage service in Azure, and the main thing of a main function and main feature of this service is to store data inside of the queue. It's one type of the storage. So it supports only simple HTTPS protocol, and you can use any service application to store the data inside of this queue. From the one hand, from the sender side, and you can use any service or application to get the data from the storage queue as a receiver. And as I said, the general feature of this queue is to store a lot of data inside of the queue. And I don't know what we can add here else, but this is a very interesting and very useful queue inside of the Azure. So now we are know what is the queue, what type of queue can be, how the queues are working, what services we have inside of Azure, and now let's see how we can use these services. My demonstration will be related with IoT process, since I'm an IoT guy and I have a lot of experience with IoT, and I will show you using of queues as an integrated service with other services inside of Azure. I will not use any code and will not show you the process of queuing, of putting the data to the tail of the queue and getting the data of from the head of the queue, but I will show you integration process, how you can set up your services in Azure to using queue in different situations. So first of all, before we will start, I want to give you a little bit more information about IoT services in Azure. First of all, the main service for communication with devices, the name of this service is Iot Hub. From one side, Iot Hub can interact with the devices using protocols that we are discussed early, using MQTT and Amqp, and also HTTPS. And as I said, MQTT is the main protocol for the IoT, and you can use it I think in every device, even in very small and cheap device like ESP. And moreover, MQTT supports TLS connection, supports encryption. But if you have only one device, if it is not a gateway that supports some amount of the devices behind it, MQTT is very good. But if you are have a gateway, field gateway, a special device that has another network behind it with a lot of other devices. For example, you have an mobile phone and Bluetooth network with connected, I don't know, headphones, watch, something more else. You will be able to use Amqp, because inside of this protocol you will be able to create different streams of data from different devices in one connection. Of course, you can do something like that in MQTT, but in Amqp it will be more natively to support different streams inside of one connection. So, and in the case then you can't use Amqp and MQTT inside of your device, you should use HTTPS. This is the most simple protocol that you can use, and only one thing that is not good in HTTPS is that it's hard to get data from the cloud, from the Iot Hub. HTTPS, it's usually, especially async data. HTTPS can be used for pulling information from the Iot Hub, but to send information to the Iot Hub, it's very good and it's very simple. And I know a lot of solutions then when you can use HTTPS to send the data. So inside of Iot Hub, as I said, we have internal event hub. By default, all information that we are receiving from the devices using these protocols will be placed to the internal event hub, and other services can get this information, these messages from this event hub using different protocols. You can take Iot Hub SDK and use its own libraries to receive the data from the Iot Hub, and in this case you will not see the event hub itself, and for you you will work only with Iot Hub. But also you can use event hub SDK. Sorry, I think I need to close.
The fight with interruptions is irrelevant.
Yes, sorry. So you can use Event Hub SDK and connect directly to the Event Hub inside of the Iot Hub, but also Iot Hub contains special feature that allows routing. So you can set different rules that will route your traffic from your devices to different endpoints. You can specify, for example, if your system already has deployed Event Hub and you don't want to other than new Event Hub to your system, you can set up the Iot Hub to use this external Event Hub, or you can send the data to the service bus queue or service bus topics. Service bus queue will have only one receiver. Service bus topic will allow you to have different receivers for the same message. So queues are a very important part of the IoT Hub. On this slide, we can see the difference. Oh, what's wrong with it? Sorry. Yeah. On this slide, we can see the difference between message routing and the event grid. As I said, this is the message routing. So we are yes, we are working with Event Hub with name Event, but we still sending the messages from our devices throughout the services. Also, IoT Hub, as we saw here, also IoT Hub can be connected to the Event Grid, and using Event Grid, we can work with events from IoT Hub itself, and the device telemetry is can be used here as an event too. So you can get the telemetry from device with the data from device and put it inside of event grid, and the event grid will put this event with the data of from the device to the other services. The general difference between them that message routing will save the order of the messages. Event grid will not save the order of the messages. So this means that you will not be able to work with the data like with the stream using event grid. When you will use other services like Event Hub or Service Bus, you will save the order of the messages, and you will be able to use the data like a stream. And also, Event Grid has much more receivers, built-in receivers for the events. Message routing, unfortunately, has not so many receivers, but you can use, for example, Event Hub or Service Bus and connect this Service Bus to other services, so you can use connection between services to fix this problem. So now we can try to see the demo. The demo will be very simple. So we will have a device. We will have a Azure IoT Hub, and we will use Stream Analytics service that will receive data from our devices and transmit data to Power BI. So in the end of our demo, we will see the chart of our information from our device inside of the Power BI. But okay, before we will start, I think to give you a little bit more information about Power BI and about Stream Analytics. So Stream Analytics is the unique service from my point of view that allow you to work with the data as the stream, as I mentioned earlier. So it can use Event Hub, IoT Hub, storage blobs, and other sources to get the data like a stream. Inside of IoT Hub, you can work with this data like database, like with the database. So you can write the SQL-like command. For example, you can write, okay, from this source, please give me the messages where the temperature is bigger than 15 degrees, and put all these messages, for example, to Power BI, or put all these messages to the database, or get the information from this device with this serial number, get all messages from this device, add to these messages information from database, for example, and then put this resulting message to the function. So this is very useful service that can do a lot of things with streams. Also, it can, for example, use windows. So you can calculate the mean value of 10 messages, or you can calculate the mean value of all messages during last 5 minutes, or you can take, for example, I don't know, the maximum, the biggest value of telemetry from last 5 minutes. So it's a very powerful service, and it can be used not only with the devices, it can be used with any data from your application or any data from database or from blob storage. Also, you can connect here the machine learning and use it to work with the streams. And as I said, you can send the result of this interaction with the data, with the streams, to different other services. And Power BI is
Alex,
BI.
I'll
Yes.
interrupt you for a second because we had a question. So, how does IoT Hub MQTT handle security to the devices?
IoT Hub supports, as I said, TLS connections, so all connections, and I think you should to know that all Azure connections, public connections, are under the TLS or something like that. So all the data between the cloud and devices or on-premise servers are encrypted, and inside of IoT Hub, there is different types of identity for the devices, and most of all, of course, are realized inside of SDK. So you are, like with other services, you can get just you can create a logical device inside of IoT Hub, get connection string from this device, paste this connection string to the SDK, to the code, and this will fix your problem with security. But inside of it, of course, it used TLS encryption and TLS connection with unique identifiers with device and IoT Hub certificates that device can check that check IoT Hub certificate. You can also use X509 certificate for device to give IoT Hub ability to check that this device is not a fake device. So all the modern systems and modern features of security can be supported inside of IoT Hub. It depends on the device. So if device can use security and certificates, it will use it. If a device can't use certificate, it will use only TLS connection without certificate and use login password, for example, inside of the encrypted channel with the IoT Hub. I hope I answered to your question.
That was quite extensive, but if there is a follow-up, I'll not let you know.
Okay. So a couple of words about Power BI. Power BI is the very powerful tool and very important tool, I think, because working with the data is not only to storing and analyzing it, but also you need to show the data to the people who are making decisions based on this data. And Power BI is allow you to get the data from the different sources, to mix this data from the different sources inside of from the different sources in the one one visual representation to transform the data, append data from one source and another source to add some calculated values inside of the data. So you will prepare, using these features, you will prepare the data set, and based on this data set, you can create different representations, visual representations of the data like this. You can you can see here just numbers or different types of graphs, and then you can create a report and dashboards, interactive dashboards, so people can click on the charts. People can switch, for example, tabs of the dashboard and switch the different views and so on. So you can easily create a huge and interactive representation of your data. And not only the representation, but also you can here create manipulation with the data, appending, transforming, and mixing from data from the different sources. So now let's try to look at the demo. First of all, of course, we are now working online. And it will be different from my side to show you a real device. So I want to use Raspberry Pi Emulator. Sorry. Oh no, let's. Oh. Okay, let's do the next. I prepared a little bit, so I opened all necessary tabs here. So what is Raspberry Pi Emulator or simulator? It's a project that was made by Microsoft team to simulate the real device. So let's see what do we have here. Here we have a Raspberry Pi board. It's a simple computer with Linux inside of it, and also you can use Windows IoT Core inside of Raspberry Pi. Raspberry Pi has different types, and now it has very powerful. Last versions of Raspberry Pi has very powerful CPU and maybe 4 gigabytes of RAM. Also, it has Ethernet, Wi-Fi, USB connections, and even HDMI connection to connect them to connect the display or monitor here. But for IoT, Raspberry Pi has a lot of pins that can be used to communicate with sensors or leads, to blink leads, and so on. So this simple emulator has Raspberry Pi connected to the sensor BME260. This is the sensor that measures temperature, humidity, temperature and humidity, and also we have a lead that can blink here. And here we have a code that can be used to connect our device to Azure. So, as I said, if we want to work with our device, we need to get the connection string for our device. Let's see how we can work with the IoT Hub. I created the resource group, Baltic meetup. So let's create here inside of this resource group, let's create IoT Hub. Oh, it seems that I take a lot of time. But okay, I think we will show the demo maybe in 20 minutes or something like that. Let it be Germany. Name something like that. Usually it deploys very fast. Yeah. We will use internal event grid inside of the IoT Hub, and while we are creating the IoT Hub here, we also I wanted to show you second link. This link is the step-by-step guide how to show the data inside of the Power BI. So we will use this link to send the data from the device to Power BI. And here later you can use this link to work with our Raspberry Pi emulator. But now I will show you how to do it on our meetup. So we need to create not only IoT Hub here. Also, we need to create where is it? We need to create resource groups. We need to create Stream Analytics service. Where is it? Stream Analytics job. Let's create it. That would be Europe. Okay, great. So what do we have? We have the IoT Hub. Here we need to add our IoT device. IoT device. New one. Device ID. Example like this. And here you can take different authentication type, symmetric case or certificates, so signet certificates or authority signet certificates. We will use default value, symmetric case with auto-generated case. So let's click Save. And wait until our device will be created. Yes. Let's go inside of this device and let's copy the primary key and paste it. Where is it? Paste it here. No, sorry. We need not a key. We need a connection string. Yes. Inside of connection string, you can see that this is the classic connection string with host name, device ID, shared access key. So it's very easy to create it by yourself, but you can copy it from the IoT Hub. So we can click run here. And now you can see that message is sending to the IoT Hub. And every time that when the message will be sent, our lead will be blinked. So what we should receive? We should receive temperature and humidity. Without any additional information, we can only wait without any additional tools. We can only wait until these boards will show us that we are working with our devices. But you can see that we are already using 4 messages. So we received 4 messages from our device. Oh, now it's 0. So these boards are will be updated a little bit later. And now what we can do to check, we can use some clients, or for example, we can use Visual Studio Code, but I will not spend your time, and I will use Azure Stream Analytics to get this data. So we need to add the only one thing. We need to add the here built-in endpoint. We need to add the new consumer group. Here to create a new consumer group for Stream Analytics, because by default we will be able to use default consumer group to communicate with the data by other services. So let's now go to the Stream Analytics job. This one, yeah. Stream Analytics job, and let's create input from IoT Hub. Input. This means you can see that we can use Event Hub, IoT Hub, both storage. When we are choosing IoT Hub, this means that we will connect to the Event Hub inside of IoT Hub by using IoT Hub endpoints, by using IoT Hub SDK. But if we will check here, this is the setting of Event Hub, internal Event Hub. And we can use this in Event Hub compatible name and Event Hub parameters to connect Stream Analytics directly to the Event Hub inside of IoT Hub. But now we will use IoT Hub connection to make it a little bit simpler. So what we will have here, my subscription, IoT Hub name, consumer group that I created early, shared access policy owner, okay, endpoint messaging, partition K, grouping, okay, let's leave it alone. JSON, UTF-8, okay. So this is the input. Now we need to create output. We want to send data to Power BI. I also authorized here, and let's copy it from here. Let's do it like this. Where is it? Where is it? Where is it? No. Alexander system. Okay, let's try to do it. The problem that Power BI can't. What's wrong? Okay. Power BI is using only working email address, and you can use only working email address to work with Power BI. So I'm using my additional subscription here. So output alias is Power BI. Notification mode, user token, data set name. Let's create my data. Table name Iot data. And now we need to create the query. So select all messages from Iot input and put it into Power BI. Let's test the query. And here we have information from our queue that stores the data from our devices. So let's device ID, temperature, humidity, event process time, event queue time, and information from our event hub. So let's save the queue. And let's start our Stream Analytics job. And now I think, yeah.
Yeah, well, it's kind of processing one question, maybe to interrupt you. So are there some economical way to filter messages events coming from Iot Hub before ingesting to Stream Analytics service? To remove duplicates or to just kind of save on consumption rate?
You can try to use Azure Functions, but for now, I think that the Stream Analytics is one of the best ways to work with the data from IoT, because you need to create some infrastructure before Stream Analytics, and you need to create some business logic that will do the same that Stream Analytics can do easily, much more easily than the infrastructure that you can create. So I can recommend you to use Stream Analytics for these tasks, to find duplicates or to separate streams or to do something with the device data.
Yeah, I imagine it would kind of be very dependent on specific use case. Because
yes, of course.
If you really can need to save on this consumption rate, then probably you need to push that computation down on your edge devices or kind of physical hubs.
Yes. You know that even Iot Hub supports the IoT Edge features, so you can work with your edge devices. This means that if you have an Linux or some operation system on your device, you can deploy their containers controlled by IoT Edge feature, and even you can put there your Stream Analytics engine and make your Stream Analytics job inside of your edge device. You can try to optimize your costs like this, for example. Or you can use some additional cloud gateway before Iot Hub. for example, and you can write it by yourself using MQTT broker and I don't know web app or virtual machine, and do your job there. And after that, you can use Iot Hub, or you can directly use Stream Analytics to work with your data.
Okay. Yeah,
So
we're running close on the time, so
yes.
Try to wrap up.
Yeah. So right now, if everything is okay, we should let's try to refresh it. Here we see that we have one connected device, and we have a lot of messages. Here we have information that we are getting information from the inputs, and if everything is fine, we have no error. That this means that here we should have some data sets. Yes, this is my data set that we can use to workspaces. We can use to create a report here. So we can create a graph here, and we can put the, for example, event produce here, and values for temperature. Yes, this is the temperature, and this is humidity. And here is it. This is our chart. We can use different types of chart here, and we can save this visual representation of the data and put it on the dashboards. So this is the simplest way to receive your data from your devices and to show it on the dashboard in Azure. There are a lot of other stuff for IoT in Azure, of course, but this is the different task, and we need a lot of time to talk about it. But if we are closing to our time, I just want to give you a couple of words about second demo. I think I will not show you this demo, but I will give you the link that you can use to work with this demo to do it by yourself. We can use Event Grid, Logic App, and Logic App to communicate with events from the device. And as I said, we can get the event that device is connected. Throughout Event Grid, we can send it to the webhook. Webhook will be captured by the Logic App, and based on this webhook, Logic App will send an email to the receiver, and the receiver will be notified by email when new device will be connected or old device will be disconnected. Here we can use Azure Logic App. It's a special service to react on some events, external or internal, and to create some actions based on the these events, and it has a lot of built-in connections to a lot of other services that allow you to not only communicate with devices, but to create huge and interesting and featured solutions to interact between different applications, different types based on event. So you can create a trigger that will receive some event. After receiving event, the trigger will fire some and start this some reaction, and the event will be processed. For example, you can make a post in Twitter, you can send information to GitHub, or to change something in Google Calendar, or even in Outlook, and something like that. So this demo will take additional, I think, 20 minutes, but as I understand, we don't have this time, so I can give you, we will share with you this presentation, and you can use this link. Let's see what we have here. You can use this link to make this demo by yourself. It's a very good exercise, I think. Yes, and you can use Raspberry Pi as the source, Iot Hub, like we are saw just before, and use Event Hub and Logic Hub to produce emails on the device connection disconnection. So this is the end of my presentation. Thank you very much. If you have any question, I can answer this question. If no, so I want to say thank you for listening to me and for coming for this meetup. And I hope that all the information that you have here is useful for you, and you learned new things. So thank you.
Thank you. Sorry to have to rush you. Well,
No problem.
Poor planning on our side. But let me just kind of give the final closing words before we stop. So everyone is invited to join our Discord server to continue the conversations around topics that were presented. Or if you're just curious about something, go drop a question. We're looking forward to that. Today's event will be, the recording for today's event will be published on YouTube channel along with the previous events video. And the presentation materials will be shared on GitHub repository. I'll send all these links also in the meetup, so you should get it also from there. If you miss it here in the kind of communication sidebar. I would kind of suggest everyone interested in Azure and kind of trying to get first certification to go check out Fundamentals virtual training days. I myself am trying out kind of this for AZ 900 certificate this week, so let's see how it goes for me. But in any case, we would like to hear feedback from you, because we want to kind of still make this something for the community, not just because we show something because we have speakers. So I'll share the link kind of for the feedback survey, and please go and fill it out. It takes just a couple of minutes to do, and I will very much appreciate if you do so. In any case, thank you everyone who joined, and have a good evening.